This video is the continuations about Python functions. Actually, what we have covered in previous video is about positional arguments. Positional arguments are arguments or input that you give to the functions that need to be put in a certain orders. Remember, the keyword here is in order. The order is important because the functions will use them in the sequence that they are given. Let's say you have a function that needs two inputs, param0 and param1. The first input that you provide will fill in the first slot, and the second input that you provide will fill in the second slot here. This way, the functions know what to do with each of the argument based on where it is placed. Take for example these functions, calculate power. These functions basically require two input, which are base val and exponent val. To call these functions, you will need to pass two arguments, and you need to pass it in a correct order. For example, if you supply the base value equal 2 and the exponent value equal 3, these functions by right should produce an out of 8. As you can see, the order of the argument is critical. If you would pass the argument in the wrong order, you will get an incorrect result. Apart from positional arguments, we also have what we refer as keyword argument. Keyword arguments lets you call a functions with input in any order you like. So keyword argument is really handy when the order doesn't matter much, or if you want to make your code much more easier to read. When you use keyword argument, you are basically give some reference name for each of the informations that you give to the functions, and for each of this reference name, you will pay it with the same value using an equal sign. This way, you can match everything up by name, and you are not restricted by where each of the arguments sit in the list of the input. So the keyword argument approach is especially helpful when you call a functions that with a lot of in parameter, and each of these key value pair will avoid mix up by making it clear of which value go to which parameter. For example, here the value for keyword 1 is equal to 0 and the keyword 2 is equal to param2. Take this code snippet as an example. These functions takes two arguments, which are base and exponent. If we supply the functions with base equal to 4 and exponent equal to 2, we know for sure without any ambiguity when the function process this info, the function should receive base equal to 4 and exponent equal to 2. Do you notice I firstly swap the position of each of these key value in the function call and the function definition. Keyword argument also helpful when a functions have an optional parameters with default values. So for example, these functions, maybe most of the time it will use the value of exponent equal to 3. By doing this, notice in line 4, we do not need to define exponent equal 3 every time. So in this case, whenever we invoke these functions, we only supply it with the base value. We only specify variable that may change frequently. So this makes our code much more straightforward and flexible. It is also possible to combine both the positional argument and keyword arguments in a single function call. So the syntax of doing this is, first you position the positional argument from left to right, then you can place the keyword argument by their names. This is some example on how to combine both the positional argument and keyword argument in a single function call. So as you can see, positional argument must be provided in the order of the parameters defined in the functions, whereas the keyword argument can be supplied in any order after the positional arguments. Sometimes we don't know how many arguments the functions will be supplied with. For instance, imagine you are making a function that print out content of a list, but you do not know ahead of time how long the list will be. In this case, you can use these cool features that lets a functions accept any number of positional argument. This is called as arbitrary positional argument. You can use this asterisk symbol before the parameter name in the function definition. The asterisk symbol tells the Python to pack all the positional argument into a tuple. Then this tuple is then passed into the function, and the function will unbox all the tuple during the operation. Let's consider this example. Here we have my functions that will take any input, and it will print all the inputs that is given into the functions. In this example, the function my function will take all the input cat, dog, bat, cow, and rat and pack it as a tuple. Then it will supply this tuple to the my functions, and the function will print all the animals. Similarly, we can easily extend the input from 5 input by adding the b and n without any major changes into the function definitions here. Even though a lot of folks use the args as the name for this parameter, but you are not stuck with this statement here. can name it whatever you want, such as Alabak, but make sure you put the asterisk symbol before the name. Similar to arbitrary positional argument, Python also offers a way to handle an arbitrary number of keyword arguments. Keyword argument is used for when you want to accept an arbitrary number of keyword argument in a function. So what we do, we simply put a double asterisk before our parameter names in the function definition. The double asterisk tells Python to gather all the extra keyword argument and pack them as a dictionary. This is slightly different than the arbitrary positional argument where it packs all the input as a tuple. The keys in these dictionaries are the argument names and the values are the corresponding arguments values. Just like with the arbitrary positional arguments where arg is the quark is the conventional names used for arbitrary keywords argument. But you are free to choose any name you like as long as it is preceded by the two asterisk symbol. This is an example of how to use the arbitrary keywords argument. You may pause this video and see the logic behind this code snippet. In Python, you can use both the arbitrary positional argument and the arbitrary keyword argument in the same function definitions. This allows the functions to accept an unlimited number of arbitrary position argument and arbitrary keywords arguments. The order is important here. Args must come before quarks in the function definitions. When you do this, the args will collect any extra positional argument into a tuple and the quarks gather any extra keywords argument into a dictionaries. This is an example of how to use the combination of arbitrary position argument and arbitrary keyword argument. In the code snippet, the function print all argument is designed to display both positional and keyword argument that are passed into it. First, the arg will collect all the positional argument as a tuple, whereas the quarks will collect keywords argument as a dictionary. Then in line 2, the compiler will print the string positional argument followed by whatever that is contained in the args. In line 3, the compiler will print the string keyword arguments followed by the content of the quark.